Fundamental concepts, basic quantities, and idealization. First, let's look at some basic quantities. They are length, time, mass, and force. The first one, length, can be used to describe the position in space, the size of a physical system, and the geometric properties of a body. Like demonstrated on the left, we can describe the positions of the endpoints and the middle point, points A, B, and C on the rod, by three sets of numbers known as the coordinates of these points. The coordinates are the three lengths measured from the origin along the x, y, and z direction respectively in the established rectangular coordinate system. The figure on the right demonstrates that the length can be used to describe the dimension and the geometric property of an object, which we should be very familiar with already. In the International Unit System or the SI unit system, the unit of length is given in meters, while in the US customary system, its unit is given in feet. Next, let's look at time. Time describes the succession of events. In other words, it describes how one thing happens before or after another and in what fashion. For example, we are all very familiar with the concept of speed, which describes the change of position of an object with respect to time. Time is a very important concept in the subject of dynamics, but in statics, we mainly deal with objects that are motionless. Therefore, we mainly deal with principles that are time independent. In either SI unit system or US customary system, the unit of time is given in seconds. Mass is a measure of quantity of matters. Mass is a physical property that characterizes the extent of force an object experiences in a gravitational field. And it also characterizes the resistance of an object to changes in its state of motion. Keep in mind that mass is not the same as weight, since weight is a force. In SI system, the unit of mass is given in kilograms, while in the US customary system, its unit is given in slugs. Now we have discussed length, time, and mass. Please note that in classical mechanics, length, time, and mass are absolute concepts that are independent of each other. The concept of force characterizes the action and reaction between two bodies or systems. There could be contact between the two bodies, like in the image on the left, or there could be no contact. For example, as shown on the right, weight is the gravitational force exerted by the Earth to the object, and no contact is necessary. Force is a vector, and it is fully described by magnitude, direction, and point of application. In SI system, the unit of force is given in newtons, while in the US customary system, its unit is given in pounds. Now let's talk about some common idealization that we use in this class. Idealization means to use scientific models to represent phenomena so that they can be simplified to an extent. An object can be modeled as a particle when its geometry and dimension are negligible for the interest of the study. A particle is considered to only occupy a single point in space with no shape or size, and it has no properties except its mass. For example, the Earth that we live on is so tremendously big, and it seems to make no sense to consider Earth as a particle. But the size of Earth is insignificant when compared to its orbit, let alone the whole universe. Therefore, when we study the Earth orbiting around the Sun, we can model the Earth as a particle, and we don't need to consider its own rotation. Rigid body is another idealization of real-world objects. A rigid body not only has mass, but also has dimensions and geometry, in other words, size and shape, that need to be taken into consideration in our analysis. But unlike real-world objects, a rigid body doesn't have any other material properties such as elasticity, therefore it will not deform. A concentrated force assumes that a force only acts on a point, although in reality, forces are applied to an area or a volume. For example, the weight of an object is distributed throughout its body, but in our analysis, we often use a concentrated force that is placed at the center of gravity in the object to replace the distributed gravitational force.